All right, so in this unit, we're going to talk about composition functions. And today we're going to talk about evaluating. There are three types of ways to evaluate a composition of function. And the first way we're going to talk about is going to be how to evaluate from an equation. Okay, so you've never really seen, you might have seen these, but in Math 3. So previous knowledge. So if you recall from Math 3, when you learned how to evaluate a function using function notation. So in Math 3, we talked about evaluating, and we talked about it when in function notation versus just giving you x equals. So if you look over here on this image, I tell you that f of x is x plus 1, and I tell you that given x equals 2. Well, in function notation, that means f of 2, and that means we replace all our x's with 2, which is what they did. So then we found out f of 2 equals 3, and in coordinate form that would have been 2, 3. Okay, so we talked about that in Math 3. Now we're going to learn another way to evaluate two functions with composition of functions. Okay, so composition functions are where one function is plugged in for the x value of another function. Okay, so that's going to be later in this unit. Right now we're going to use evaluating, but it's still the same concept. Okay, you plug x into one equation, you get an answer, and then you plug it into the other equation, and that's your final answer. Now, it's a different notation. Okay, so if you look right here, this right here is saying f composite g. It is basically means that you're going to take your g of x and you're going to plug it into your f of x. Okay, or you could say g composite f, which means you're going to take your f of x function and plug it into your g function. We can also evaluate using composition functions too. So what does it look like to evaluate with this? So they're going to give you two equations. Sometimes you can have three. Okay, we're going to do a 3-1 in here. All right, so there are two ways to denote this, as you just saw. Okay, you can say g composition of f of -1, or you can say g of f of -1. All right, they mean the same thing, and I like this notation the best. So if you're given this one, I always convert it to this. Okay, so I'm given two equations. F of x equals 2x squared minus x plus 1, and then g of x equals f of x equals 5x plus 15. Okay, so it is telling me that I want to find g of f of -1. So what that means is that I need to first find f of -1, then I can find my final answer. So it's like you work inside out. Okay, so you take care of the inside function first, then you do the outside function. So I'm first going to find f of -1. All right, so that means I'm going to replace all of my x's in f of x with -1. And I've told you before, when you have a negative number you're plugging in, please use parentheses. It's going to help you out so much. So when I type all this in my calculator, I get the answer to be 4. But that's not your final answer, because that just takes care of f of -1. So I now can replace f of -1 with 4, and I have g of 4, which means I'm going to replace all of g's x's with 4, type that in my calculator, and I get my final answer to be 35. Okay? So let's actually do some, because that'll help out. Okay? All right, so let's try. I have, it says given h of x equals -3x plus 5 and g of x equals -x plus 4, I want to find h composite g of 9. Well, that's not the notation I like, so we're going to convert it to the one that I think is easier to read. And we're going to say, so all you do is replace this composite symbol with a parentheses is really all you're doing. So I'm going to say h of g of 9. And I want to know what that is. Okay? So we're going to work inside out. So first let's handle the inside piece. So first we're going to take care of g of 9. So that means in the g function, I'm going to replace all my x's with 9. So I have negative, when I come to an x, replace it with 9, and then plus 4. So then use your calculator or Desmos, and we're going to say -9 plus 4, and that's going to give me -5. So now I know that g of 9 is equal to -5. So therefore, I can replace g of 9 with -5. So now I have h of -5. And that means I'm going to replace all of my x's in the h function with -5, and I get -3 times -5 plus 5. I'm going to type this in my calculator. And I get my answer to be 20. And that is your final answer. Okay? So it's a two-step evaluating process. Okay? You evaluate it one time, and then you have to evaluate another equation. Okay? All right. Next one. This one, so I alternate between both notations, okay, so you can get familiar with both of them. So this one says given f of x equals 2x and g of x equals x squared plus 3, find f of g of -8. There should be another parentheses here. So you're working inside out. So first I need to figure out what is g of -8. So let's figure out that. G of -8 means I'm going to take my g function and replace all my x's with that number. Now it's a negative number, so please use parentheses. So I'm going to say -8 squared plus 3. Use your calculator or Desmos, whichever one. And I get this to be 67. Now I'm not done because now I've simplified this to f of 67. So now I need to figure out what f of 67 is. So I'm going to take my f function and replace all its x's with 67. So I'm going to say 2 times 67. And my answer is 134. And that is your final answer. Okay? All right. Next one. So this one, sometimes you won't get two equations, you'll just get one, but it's okay. You're just going to evaluate the same equation twice, but with different numbers. So this is saying given g of x is 2n minus 5. Oh, that should not be that. I'm sorry. That should be x. My bad. So 2x minus 5. So it's saying find g composite g of 5. So we're going to rewrite that. Just change that composite to a parentheses. So we're going to have g of 5. So you're going to evaluate the g function twice, but with two different numbers. So again, start inside out. So I'm going to start with g of 5. So let's first find out what g of 5 is. I'm going to replace all the x's with 5. So I'm going to say 2 times 5 minus 5, and that's going to give me 5. Whoops. Okay. Then, well, I guess you're going to evaluate the same number. That worked out interesting. So I'm going to replace g of 5 with 5, and I get to find g of 5 again. And so this is one of those coincidences where your answer is the same thing. Okay? That doesn't happen all the time with the same function. It just happened to happen with this equation, okay? Which is fine. All right? Answer is an answer. All right, so next one, let's throw some square roots in there, all right? Excuse me. All right, so this one says if f of x equals -9x minus 9 and g of x equals the square root of x minus 9, find f of g of 10. So it's in the notation I like, so I need to find g of 10 because we work inside out. So first find g of 10. So I'm going to replace all my x's in the g function with 10. Now this is the square root. You simplify underneath the radical before you take the radical. So it's going to be the square root of 1, which is just 1. Well, you could have used your calculator if you wanted to. So now I have that g of 10 equals 1. So I'm going to replace g of 10 with 1. And now I need to find f of 1. So f of 1 means I'm going to replace all of f's x's with 1. So I have negative 9 times 1 minus 9. And that's going to give me negative 18, which would be my answer. Okay? All right. So how about you pause the video and try this one out on your own, okay, and see if you can get this one correct, okay? All right, so pause the video, give it a shot. All right, I hope you paused the video, and now let's see if you got the correct answer, okay? So this is H composite F of negative 2. So we're going to switch it to the format that we like. H, you can't really see that color. Let's go to a darker color. So we're going to have H of F of negative 2, okay? So I first need to find F of negative 2 because we work inside out. So F of negative 2 means I'm going to take all of F's x's and replace them with negative 2. And we're going to use our parentheses. So negative 3 times negative 2 plus 4. You can type this in your calculator. You can do it in your head. You can use Desmos. I get 10 to be the answer. So f of negative 2 is actually 10. So I'm going to replace f of negative 2 with 10. And now I need to find h of 10. Okay? So that means I take my h function and replace all the x's with 10. So now I have 10 squared, which equals 100. So my final answer would be 100. And I hope you got that as your final answer also. Okay. All right. Next one. I want to find, so this one, okay, so this one's different. It gives you 3 equations. So we're going to do 3 evaluations, but you do the same thing. You work inside out. Okay. So don't let it freak you out. Same thing inside out, okay? So the first thing we want to do is we want to find f of 2 first, okay? Because that's the inside. Let's find f of 2. So I'm going to take the f function and replace all the x's with 2, which would be negative 2 times 2 plus 1. So negative 2 times 2 plus 1 is going to give me negative 3. So now I can replace that inside with negative 3, and I have h of g of negative 3. Now we're down to what we've been doing, right? So now we still have an inside, so let's fix that inside. So I need to find g of negative 3. Okay? So I'm going to take the g function and replace its x's with negative 3. Okay, so I'm going to do the square root of negative 3 squared minus 5. Okay, please use parentheses, especially when you're dealing with squares and you're using a calculator. Okay, so negative 3 squared minus 5 is going to give me 4, and the square root of 4 is going to give me 2. Okay, all right, so now I'm going to replace g with 2, okay? So now I'm going to replace that. So now I'm going to find h of 2, all right? And so now h of 2, we're going to take all my x's and replace them with 2. So it's going to be 5 times 2, which would give me 10. So my final answer is 10, okay? All right, let's do one more, I believe. Yep. All right, so last one. Okay, we're going to do the same thing. All right, so it's 3 equations, and it's not written the way I want it, so we're going to change all those composite symbols to parentheses. So it's g of f of h of negative 4. I wrote it wrong. Then we got close. There we go. All right, so inside out. So first I'm going to find h of negative 4, okay? So h of negative 4 is going to be 7 times negative 4, which is negative 28. Let me just make sure. Yeah. So now, that one was easy. So now I can replace the h of negative 4 with negative 28. And I have g of f of negative 28. So now I'm going to find that inside. I'm going to find f of negative 28. Okay. So I'm going to use the f function and replace all the x's with negative 28. So 3 times negative 28 minus 1. So I'm going to say 3 times negative 28 minus 1. And I get negative 85. Getting some big numbers here. Well, they're low numbers because they're negative, but big negatives. So now I can replace the f of negative 28 with negative 85. Sorry, that should be, yeah, that's right. So now I'm going to find g of negative 85, and that's going to give me my answer. So the g function, I'm going to take the g function. Oh, we're going to get a big number with that squared. All right, so I'm definitely going to use my calculator because I don't know what 85 squared is. If you do, that is fantastic. So, Lord. So my final answer is 14,447. That's a lot of fours. That would be your final answer. Okay? All right, so that is it for this lesson of evaluating the equations. Look out for the next video. That is going to be evaluating from a graph. It's less algebra. It's just looking at a graph. So it'll be nicer. All right, guys. Talk to you soon.